time to undo some of the multiplication. And when we undo multiplication, that is the idea that we're going to factor a polynomial, so find the things that multiply together to produce that product, right? So just as we might say, well, if we don't know how 45 factors, you probably do, you would make a factor tree, right? 5, 9, and then you would split it into 3 and 3. So now we're doing the same idea of breaking the given thing down into its pieces, just with variables, okay? So the first method that we're going to do, and I should probably erase this so you can see the whole thing, is that we're going to look for a GCF, greatest common factor. So we're going to look at the polynomial, see if we can see any patterns in the polynomial, and then if there is a pattern among all the terms, we're going to pull that out. Okay, so I have 3 examples dotted here. We're going to look at each of those. So if I look at the first one, 4m squared n plus 16m cubed plus 8m. Okay, I want you to look at that for a minute, pause the video, and tell me what is common among all the terms. Well, certainly I think you could maybe say that if you look at the coefficients are all even, so there's a 2 involved. So we could divide each of those by 2 and pull something out. But in fact, you could probably go a little bit further. You look at each of the terms and there's a 4 involved in the factor. So, 16 is like 4 times 4, and then 8 is 4 times 2, okay, and 4 is 4 times 1, okay? So what we're going to do is we're going to factor out a 4. And when I factor, that's a lot like dividing, okay? And in fact, well, it's undoing distribution. And when we did distribution, that was multiplying. So we're going to factor out a 4. So this first term, we'd have m squared n plus 4m cubed plus, not 8 anymore, 2m. Okay, and then just to check, again, it's good to check, you could distribute the 4 to each of the terms if you wanted to make sure that you did everything appropriately. Okay, but now I think I can go further. I think I can say, looking at these terms inside here, there's even more in common than just a 4. There's actually an m, as in Mary, involved in each of the terms. So I'm going to say that I can factor out an m, which is dividing each term by m. So this first term, we could really think of it as m times n. So then when I take this m out, I'm left with m times n left. And then again, this one would be 4 times triple m. And I take one of the m's out, that goes here. Okay, so plus 4m squared, and then the plus 2, well, this is 2 times m, I take the m out, and I'm left with 2. Now, common question that students ask is, well, Professor Wright, you took out an m from each thing, so you took out 3 m's total. Well, yes and no, right? I did take an m out of each term, but remember that when I'm taking out the 4 and taking out the m, that actually means that I would later distribute that back into each of the terms. So if I wanted to check, if I do the distribution, I'd get 4m squared n plus 16m cubed plus 8m. Okay, so it does check out when I do the distribution. So even though it seems like we're taking out 3 m's, we're looking at each term and saying, what do the terms have in common? What are their common factors? I'm going to take the common factors out. Okay, so now the next one, I have 3 more dots. I'm going to do one that's a little bit more challenging in that it's not quite apparent what the common factor is. Okay, so there's an x to the minus 4 and x to the minus 7, and if you want to write this as 1 over x to the 4th minus 1 over x to the 7th, I'm totally okay with that, because that's what it means. Okay, so now in this one, there's mathematically, there's a few different ways you can look at a GCF, but at the end of the day, what you need to recognize is that the denominator here in the first term has 4x's, and then the denominator in the second term has 7x's. So that's 3, 4, 5, 6, 7. Okay, so what I'm going to do is say, well, between the two in the denominator, there are 3x's there's 4x's in common. Like this has 4, and this has another 4. So if I factor this out, I can take out x to the fourth in the denominator, which is those 4x's, and I would be left with 1 minus, and then the second term has 3x's unaccounted for yet, so 1 over 1 minus x cubed. Now, this is fine. What some people do is instead, and this is kind of an expert level sort of thing, is they would take out x to the 7th, right from or x to the 1 over x to the 7th, I should say. 1 over x to the 7th. And then what they would be left with is x to the 3rd minus 1. Okay, this is a little challenging for students to see, so if you can see it, great. I'm going to say this first one is fine with me. Okay, for the other ones, I'll write them out here. 2x plus y to the 6th plus 2 in parentheses 2x plus y to the 2nd. So that's another one, and then the last one that we would do is 3x to the minus 2/3 minus 6x to the 1/3 plus 3x to the 4/3. Okay, so I want you to pause the video, see if you can get these factored to some degree, and the main question I want you to ask is, as you look at the different terms, and again, here you have 1 term, here you have 2 terms, here you have 1, 2, and 3 terms. What is common among the terms? And when you find that whatever's common, take it out. Pause the video and try them out. Okay, well, hopefully you had a chance to do that, and what I found was this first one, 2x plus y squared, was common to both. This one had 6 factors, that had 2 factors, so the first term I'd be left with 4 factors remaining. And then, but the second term, I actually ended up taking both of the factors out, so I'm just left with a 1. Okay? This, forgetting the 1, is like the #1 thing that students forget to do. Okay? If you take out all the factors, there has to be something there, because remember, you have to multiply it back in. So make sure to leave the 1 if you factor everything out. This next one, this is kind of another challenging one. You would take out a 3 for sure, and again, it kind of depends on your perspective. An expert would probably take out 3x to the minus 3/2, and then what we would be left with is 1 plus, 1 minus 2x plus x squared. That's what we would be left with. You could pull out something else. Maybe you want to pull out a 1/3 and go from there. But this is what we will use, and I want to come back to it in a later video. So we'll get some practice with factoring, and as always, if you are kind of not sure about this, make sure to ask questions.